Sometimes the tables and numbers and utility figures just overwhelm people. Is there any other way to determine what a consumer's buying decision will be given income, prices, and preferences? Yes, indifference curve analysis will give us a visual way to determine a consumer's choice. The setup will take a little time, but once the tool is in place, it becomes extremely simple to determine consumer equilibrium. There are three underlying assumptions to indifference curve analysis. I'm not going to test you on these, but I will occasionally refer back to them. Assumption number one says that consumers can rank preferences, and all this really means is that you know what you like. You can put goods and services in order of the most preferred to the least preferred. Assumption number two, consumer preferences are transitive. This one says that each consumer is logically consistent in his or her choices. For example, someone asks you whether you prefer vanilla ice cream or chocolate, and you say vanilla. Then that person asks if you prefer the chocolate ice cream or strawberry, and you say chocolate. This means that given a choice between vanilla and strawberry, it must be the case that you would prefer vanilla. Assumption number three says that more is preferred to less. Okay, so we know from the chocolate chip cookie experiment that this is not always true. There comes a point where the added utility of another cookie became zero or even negative, causing overall happiness to fall. However, for this model, we will assume that the consumer never gets to that point, so that the total utility does not fall. Okay, let's get to the setup now that we're done with the three assumptions. Suppose that bundle A represents 2x and 10y. No, not x and y, that's too abstract. Let's use actual products, like x is fast food combo meals and y is CDs. Now, bundle B represents 9x, 9 meals, and 3y, 3 CDs. I'm going to ask a consumer which bundle he or she would prefer, 2 meals and 10 CDs or 9 meals and 3 CDs. If the consumer, upon considering, decides that either combination would be just as good, giving equal happiness, then that consumer is indifferent between the two. There are theoretically an infinite number of such combinations, so that we end up with an entire curve upon which any 2 points would yield equal utility to the consumer. Now what if I ask the same consumer to compare bundle A, 2 meals and 10 CDs, to a new combination, bundle C, 4 meals and 10 CDs? Which one will the consumer choose? Because we've assumed that more is preferred to less, this consumer must choose combination C, 4 meals and 10 CDs, over combination A, 2 meals and 10 CDs. This means that bundle C is on a new indifference curve, one that yields a higher level of utility. How many of these indifference curves does a consumer have? Every consumer has an infinite number. Where does the consumer want to be? On the highest possible indifference curve, meaning that this individual wants to keep moving in this direction. What stops the consumer from moving higher and higher forever? Their budget. It's like a big brick wall preventing you from being infinitely happy. While the indifference curves show what you want to consume, the budget constraint shows what you're capable of consuming. What does the budget look like? Well, think about it. In order to determine your budget, what do you need to know? You need to know your income, what products you'll be buying, and the prices of those products. So let's say our consumer has an income of $100, consumes product X, combo meals, and product Y, CDs, where the price of the combo meal, product X, is $5, and the price of Y, the CD, is $10. If the consumer spends all income on just CDs and combo meals, what does the budget look like? Well, let's start with the extremes. If this individual spends the entire $100 on food, not buying a single CD, how much food can he or she buy? If you have $100, spending it entirely on $5 combo meals, the most you are capable of buying is 20 meals, even if you purchase new music. What if I consider the opposite extreme? What if my consumer spends all $100 on music and nothing on food? You could buy at most 10 CDs even if you purchase no food. How else could the income be spent? Anywhere between the two extremes, where the slope of your budget line is the ratio of the two prices. In this case, there's a 2-for-1 trade-off between CDs and meals. This line is your budget constraint, showing all combinations of X and Y, in this case food and music, that you can purchase if you spend all of your money. This concept may remind you of production possibilities, where we looked at the most that could be produced within a given amount of resources. We could actually think of the budget constraint as a consumption possibilities line, showing the outer boundary of what the individual is capable of consuming with a fixed level of income. What if the consumer wants more, like point H? This combination is currently unattainable with the current income. What about a point like I? The consumer would not be using all of his or her income and so could consume more. Will this always be the budget? No, not if any of the components of the budget change. Consider a change in income. If income doubles to $200, I'm now capable of purchasing double what I could before, so the budget constraint shifts outward. Similarly, if your income is cut in half, maybe you go on unemployment, your budget constraint shrinks. Now what if price changes? Say your income is back to the original $100. Let's say that because of flooding in the Midwest, there's been damage to the farms and we don't have as many cows, causing beef prices to go up. So your combo meal price, the price of X, doubles. How many meals can you purchase at most? You can now purchase only 10 meals. What about CDs? Well, since income is unchanged and the price of CDs is unchanged, you're still capable of buying a maximum of 10 CDs. The new budget constraint is lower than the original because that increase in price is eating away at your income. The consumer sees the budget constraint rotate inward along the x-axis, illustrating the shrinking ability to consume. What if price falls instead of rising? For example, what if, due to the availability of music online, CD prices start to fall? If income is still $100 and your price of X is back to its original $5, but now a CD costs $5 instead of $10, what happens to the budget? The maximum number of meals is still 20, but now instead of only 10 CDs, you're capable of buying 20 CDs. The outward rotation of the budget line, along the y-axis in this case, reflects the increased buying power of your money. You're now capable of consuming more. Note that while I changed only one variable at a time, income, then price of X, then price of Y, it's certainly possible for more than one to change at the same time. As an exercise for yourself, try to work out what would happen if, say, income and prices change together, or if one price rises and the other price falls. What was the point of all of this? Remember that we wanted to determine, based on a consumer's budget and preferences, how much of each product he or she would choose to consume. Remember, the indifference curves represent your preferences or your desire to consume. The higher the curve, the better. While budget constraint represents your ability to consume. So let's put the desire to consume together with the ability to consume. What point combination will the consumer choose? The consumer will choose point B. This is the highest possible utility level that's achievable for this consumer given this particular budget. Why not choose a point like D? Well, point D does not yield maximum possible utility because not all the income is being used. The consumer could reach a higher utility level by using the rest of the income for additional consumption. Well, why not a point like E then? Point E shows a higher utility level than any of the other points illustrated here. There's not enough income to reach point E at the moment. Someday maybe, but not right now. Well, points A and C are both on the budget line. Why not choose one of those? The problem with points A and C is that while all income is used, it's not used in such a way as to yield the highest possible satisfaction. In both cases, the consumer can reach a higher utility level by rearranging consumption. What happens to your consumer choice when the budget changes? Consider the possible reasons that the budget changes. Change in income, change in the price of product X, change in the price of product Y. Let's take a look at what happens in each case. For each scenario, start with the consumer in the equilibrium position. Scenario 1, you get a raise. What's the result? This consumer chooses to buy more of both products X and Y, or food and music, yielding higher utility. Scenario 2, you lose your job. What's the result? With less income, the consumer is forced to consume less of both products and is now at a lower level of utility. Scenario 3, burgers get more expensive. The price of product X is increasing. What's the result? Note that not only does the consumption of the burgers decrease, see X is getting smaller, but Y also decreases. This consumer cuts back on CDs as well. Why do you think this is? Scenario 4, burgers get cheaper. Result? The less expensive food frees up additional income, which this consumer uses not only to buy more food, but also more music. Scenario 5, CDs get more expensive. Result? The consumer cuts back on both X and Y, that is food and music, as purchasing power is reduced. And lastly, scenario number 6, as CDs get cheaper, what's the result? Because the cheaper CDs increase the purchasing power of the consumer's income, this is going to allow him or her to purchase more of both products. Next time, producer theory.